Wyatt.
I use the restroom.
Okay, so please put your block and your name. We are block D, right? And our newest chapter is called Solving Equations. All right, and this booklet feels a little bit thicker than the last one. Our last two chapters were really short. We did them like in 3-4 weeks each. This one, I'm thinking will probably be done somewhere towards the end of April. It'll take a little bit longer, but not too much longer. Okay. Now, fair warning. People are probably usually frustrated on the very first two lessons. So the first two lessons of this new chapter are kind of a review of grade 8 and introduction to grade 9 kind of stuff. So we're looking at solving equations and figuring out the value of x. So most of you guys should have done this last year. I know there were some teachers away, so may not have much experience with it, but I'll go slowly through it. Right? And so if you look at this, right, it's not too bad. The stuff looks kind of small, but this is where the most frustration happens, because we're going to talk about the rules. You got to learn the rules. Usually, by the end, students will be like, Mr. Dhaliwal, I find this easy. You'll have brackets, you'll have equations, and you'll have fractions all over the place, and you'll be doing it no problem, right? Usually, the frustrations are the most on day 1 and day 2. After that, things start clicking in and it becomes really easy. All right. So day 1 is going to take us the longest. All right. I'm going to break this up. I broke the assignment up into 2 parts. So we'll get day 1 all fully done before spring break. I'm not sure if we'll start day 2, and day 2 will start after spring break. Okay. All right. So now this is called solving equations, but it's sort of a continuation of our polynomials. And most of you guys did really, really well with polynomials. Because what we had with polynomials is just this part, right? And that was called an expression. Now what we're doing is we throw on an equal sign and we have stuff on the other side of the equals. Okay? So now, as soon as we throw that equal sign on, it changes from the word expression to an equation. So these things are called equations because we have 2 parts. We have part, if we split it at the equal sign, we don't split it at the middle. We call it the middle, but the middle is the equal sign. We have 2 parts, and we have an expression on the left side of it, like we did in a polynomials unit, and we have an expression on the right-hand side of it. So we have 2 expressions, and there's an equal sign between it. That means they have the same value, or the word equal value, right? And you've been doing this since grade 7, right? And things are going to get a lot more complicated here, but you've seen this kind of stuff since grade 7. So in the earlier grades, you may have seen like a scale, right? That sort of symbolizes that, hey, both of these things have the same value. They may not look like it. So on the right-hand side, we have 5. The value here is 5. That's easy to see. The right side, we have numbers and letters. It's hard to see what the value is. But these two things are the same value. So we have a scale saying, hey, these things are equal to each other. And so if you look at it, we have 5 dots here for the 5. We have a 1 dot here for the 1, and we have 2 x's. Just saying these things are the same value, and our goal for all of these things is always to figure out what the letter it equals by the end of it. So before we get there, we need words to help talk, right? We have 1, 2, 3 numbers and a letter. What is this letter called mathematically? Samira?
A variable?
Yeah.
Variable?
So all the letters are called variables. So we use X a lot. But it could be A, it could be C, it could be D. It could be the letter Y. I use Y a lot. Right? Those are called variables. All right? Now, there are actually 2 different kinds of numbers. I have the number 5 here. It's called the same thing as this number 1. But there is a different style of number, which is this 2. Okay? 1 and 5 are called something different than 2. We've talked about all their names in the past. Let's talk about 2 first. 2 is a number attached to a letter, attached to a variable. What are those called? Samira again?
Coefficient.
Coefficient. So 2 is called a coefficient. All right? Then we have those green numbers there. All right? Those are numbers not attached to letters. They're called something else. And it has a name with a C as well. You remember this one?
Constant.
Constant. And that one I mentioned briefly in January when we were doing the first part of polynomials. Constants. Right? All right. Now the key to success in this chapter is to be able to look at an equation like this and see all the math operations. Some math operations are easier to spot than the other. When I use the word operations, I mean adding, subtracting, multiplying, and dividing. So if you look at this statement right here, this equation, how many different math operations are there? Right? Samira?
2.
2. You are right. What are those 2 operations?
2 times x plus 1.
All right? So we have a times and a plus, she said, right? So the plus is the easy one to spot here. This is our operation. Maybe I'll highlight it in black. Right? We have a plus right there. So the plus and the minuses are usually the easiest ones to spot. Dividing is usually not too bad. Dividing is sometimes you'll see it with a symbol like this or a fraction, 5 over, or let's say, maybe let's say x over 5. Remember, a fraction is just a division symbol, right? So division is not too bad. You can usually see it is either like this or a fraction line, which means to divide. Multiplication is often the trickiest one to spot, right? We're used to seeing timeses or dots, right? If it's written like that, that's easy to spot, but sometimes it's not written like that. Sometimes it's just 2 things touching. Whenever you have 2 different things touching, there's an invisible multiplication right there, right? And so that one's the hardest one usually for students to spot, right? So if you can find all the operations, you can figure out a plan to figure out what the unknown variable is, right? And to do that, we always do the opposite calculations, right? So we have 4 operations: adding, subtracting, multiplying, dividing. Each one of those has an opposite calculation, right? So if I asked you, all right, so let's go here. So to solve equations, we do the opposite calculations. And the official math word for opposite is inverse. All right? So we do the opposite calculations, the opposite operations. If I give you addition, what's the opposite calculation to addition? Well, subtraction, all right? So adding and subtracting are opposites of each other, all right? So you have adding and subtracting. These 2 things are opposites of each other, okay? And I'll show you how to execute it in a little bit. Then we have multiplying. Multiplication. What's the opposite of multiplication? Division, all right? You can write down the word division, or how about we just do the symbol, all right? What's the opposite of division? Therefore, it is multiplication. Multiplying, so that's our x. Sometimes it's a dot. Sometimes it's a number touching a bracket. Right? There's lots of ways multiplications show up. Okay. All right. So let's get started. All right. So we're going to get started here. And now the first 3 questions we are going to do is something that you should be able to do from grade 8. Now, you may not remember it because it's been a year since you've been doing this in grade 8. but I'll walk you through, all right? So what we do is we always split our equations at the equal sign. So we find the equal sign and we split it down there. All right, we split it down here. So all three of these, I'm going to split it like this. Okay, not too bad. All right, so we split it there. So let's focus on the first equation. All right, so the goal is to always figure out the value of x, right? Or whatever the variable is called. And that the math phrase for that is called isolating the variable. That means, hey, we want to get the x all by itself, and any other numbers on the same side of the x need to go, right? So what we do is we go, okay, then this really helps when the questions get complicated. Just cover up the side that doesn't have the letter. It helps focus your mind. You go, so I do this with my hand. You can do just put your eraser on top of it. You go, okay, on this side, we want the x all by itself. That means that 3 needs to go away, right? To make it go away, we always do the opposite calculation. So the question you ask to yourself in your mind is, what is the math operation between the number I'm trying to get rid of and the letter? So between the 3 and the x, what is the math operation there?
Multiplication.
Multiplication, right? And so you go, okay, to get rid of it, I just do the opposite. And you just go, okay, opposite is dividing, right? So what we're going to do is, don't write the next part down, is we're going to work on our math grammar. So last year, your teacher might have said it was okay to do something like this, divide by 3, right? And we're not going to do that this year. Not that that was wrong if your last year's teacher taught you that. In grade 8, all of your answers were nice round whole numbers. And so you could go like this and it always worked out. This year in grade 9, you got to be able to do fractions, right? And so a lot of the answers are going to be fractions. So this format of division doesn't really work out well for fractions. So instead of saying divide by 3 like this and this on both sides, please remember, whatever we do to one side, we have to do to the other because we want to keep things balanced, right? Remember, these things are balanced. The left side is balanced with the right side. If I cut this side down by 1/3, it becomes unbalanced. So I have to do the same thing to the other side. All right? So I go, okay, I want to go divide by 3, and all we're going to do is change our format first and use the fraction format. We can go get rid of these. Now this is what you can write down. I want to go like this. Fraction line, divide by 3. And do that to both sides. So these should look symmetrical. All right? Can you put that stuff away? We'll focus on the math and eat later. I don't know whatever is going on between you guys here. All right? So you want to go divide by 3 like this. And your page should look very symmetrical. Whatever you do to one side, you go to the other side. If it doesn't look symmetrical, chances are you made a mistake. Okay, so now you figured out how to get rid of it. Now we just do our calculations to get rid of it. And we use our stuff that we learned in November. So when we're dividing fractions, remember, if you have the same number on the top and the same number on the bottom, they cancel each other out. Because 3 divided by 3 is 1. So we just go like this. Cross out, cross out. Those 3's are gone. And leave it x. Technically, there is an invisible 1 in front of here, right? But we don't show that invisible 1. Right? The 1 coefficients we don't show. Right? All right. And then the other side, we clean that up as well. We go, okay, 6 divided by 3, we do that calculation. And you go, oh, 3 can fit into 6 twice. Right? And we just do that division. Now, if you couldn't fit in perfectly, you would just simplify that fraction. Right? Either you divide the number or you simplify it as much as you can. And that's it. That is our final answer. And that's how I want your work to look like. Because as the questions get more complicated, if you're sloppy with how you do your writing, you're going to end up with wrong answers. Right? Because I showed you the back end of the pages. You got brackets, you got fractions all over the place. So use the simple examples to get good at writing your notation. Okay. So now, next one. Same thing, all right? We cover up the side that doesn't have the letter, You go, okay, I want to get rid of the 3 on the other side. What is the math operation between the 3 and the letter? Right? So we have, between the 3 and the letter, we have that fraction line. So what operation is that?
Division.
Division. So we do the opposite of division, which is multiply. Now, sloppy notation. Don't write this one down. Often, students will go, okay, you have the right idea, and they'll write down times 3 like this on the bottom. They say, I want to get rid of this 3 and I'll do times 3. That's not where it goes. So the times 3 goes on the top like that. And I'm going to use a dot instead of an x because the x, we have an x variable here. Right? And I do the same thing over here. All right? So now why is that important and not to put on the bottom? Because we're using the same fraction rule as over here to get rid of that 3. A number on the top cancels a number on the bottom on a fraction, right? So this 3 on the top cancels this 3 on the bottom. So if you put the times 3 on the bottom, it doesn't really imply that now, does it? Right? So those 3's go away, and you're left with the x. And the other side, we do our calculation. What are we left with on the other side? Right? Gauge?
2.
Not 2. We said 6 times 3.
18.
18. Thank you, Adrian. All right? That's it. All right? Okay. Next one. We go like this. We cover up the side. Okay, we want to get rid of the 5. We look for the operations between the 5 and the letter, which is this here. Right? So what's the opposite calculation we're going to do? Gauge? Adding. So to show adding, we're going to do like our polynomials unit. Adding and subtracting, we're going to stack things. All right? So we go like term with like term for adding and subtracting. So I can go plus 5 right here. All right, so right underneath it, I'm going to go plus 5. Just like we did in our polynomials unit. Right? And whatever we do to one side, we do to the other side. We increase this side by 5, we're going to increase the other side by 5. All right? Okay, so now we do our cleanup. We have a minus 5. Also means the same thing as a negative 5. Right? Minus and negative signs mean the same thing. We have a negative 5 and a positive 5. Those two things cancel each other out to make a 0. So we just left with the x. On the other side, we have 11 plus 5, or 11 and a positive 5. Those two combine to make what number? 16. Right? So all of 3 of these questions are something similar to what you would have done in grade 8. Right? We're going to go up one notch more higher in difficulty. Right? Not much more difficult, but make you think. All right? So here we go. We have the equal sign. We split it at the equal sign. That splits our equation up. We cover up the side that doesn't have the letter. All right? So we want to get rid of that 3. Right? So what is the math operation between the 3 and the x? Times, right? Okay, so we do the opposite, which is divide. So we show our dividing with a fraction line. So you go divide by 3. Now we're supposed to do the same thing to the other side. But we have a little bit of an issue. What's the issue? Do you guys see the issue? There's already a 3 sitting here. It's not like this other question where we just copied exactly what we did, the very first one we did. And there was an empty spot below the 6, and we just did divide by 3 underneath it. The empty spot, the denominator, is already taken up here. Right? So what we got to do is we still got to divide by 3. We just got to put it off to the side. Just put it off to the side because we need to do the same thing. Now, we can't just have a number floating around. Right? So what we do is we go put a little times dot and a 1 in here. Because dividing by 3 and multiplying by a third means the same thing. dividing by 3 and multiplying by a third means the same thing, right? So we're still keeping things balanced. Now we do our cleanup. We try to figure out what the value of x is. So the left side is the easy one. A number on the top cancels the number on the bottom, because 3 divided by 3 is 1. We're left with the x. On the other side, we have to go back to November in our minds. How do we multiply fractions? How do we combine these two fractions together by multiplying them? You guys remember that? Avelina?
See if you can simplify either the top or the
Yeah.
bottom, and then you just multiply the tops and the bottom.
Yeah. So there's no simplifying that we can do. So we just multiply the tops together. 2 times 1 is 2. And 3 times 3 is 9. So the answer is 2 over 9. Okay. So all of a sudden, a little bit more difficult because the numbers look weird. Still, we didn't change what we did. The process is the same. You just need to know what the format was. Now, the good thing about this chapter is if you're willing to put in a little bit extra work, you can always check to see if your answer is right. Right? So I'll show you how to do that. I'm not going to ask you to do it a lot. I'll ask you to do it every once in a while. Right? So how do you check to see if your answer is right? So the math word for check is verify. Verify your answer. Verify your answer. And when you get to grade 11, you can do a lot of what we're going to do right here, right? So what we do is we start off with one side of the equation, right? And we make it look like the other side. So you start off with the side with the letter, right? Oh, and we're taking notes here, right? So you start off with this side of the equation. You go 3x. And just above it, we write down the letters L, H, S. Any idea what LHS stands for? No idea? Okay, so left-hand side. This is just saying, hey, I'm starting with the left-hand side. Sometimes you may want to start with the right-hand side. All right? This is my left-hand side. This is what it looks like. And by the end, hopefully it looks like the right-hand side. All right? So we go, okay, this is what we started with. And now our guess is when we did our calculation, our answer was 2 over 9. So where we see x is we're going to put that in. So remember when we replace letters with values, we do it with brackets. 2 over 9. Right? Alright, so now we need to multiply these fractions together. Remember that 3 technically has an invisible 1, right? So we multiply the tops, we multiply the bottoms, and we go 6 over 9. Because 3 times 2 is 6, 1 times 9 is 9. Right? And we go, oh, the left-hand side equals 6 over 9. And we have a problem because we wanted the right side to equal 2 over 3. So is 2 over 9 the wrong answer? I see Evelyn shaking her head. What can we do?
We gotta simplify them.
We can simplify our answer, right? Both of these numbers can be divided by 3. So if you divide both of these by 3, you get 2 over 3, which equals the right hand side. Right? And you know your answer is right. Now, for most of the stuff you can do like this. If you're really good with the fractions unit, remember, Evelina mentioned this earlier, we can always simplify before we multiply, and that's the step I encourage you to do because you're sort of going to have to do it later. You could say, hey, I noticed that, hey, both of these could be divided by 3, and we did this kind of stuff. All right? So I encourage you to simplify like that first. Because 3 and 9 can be both divided by 3. So 3 divided by 3 is 1, 9 divided by 3 is 3. Then we multiply. 1 times 2 is 2, 1 times 3 is 3, and you get the same answer. Right? So different path, right? Usually as numbers get harder, this is going to be a little bit better, okay? Now, next part, not needed, but when you get into grade 11, then you'll add these 3 letters at the end. QED. Right? And those are Latin letters to say, this is how it's been demonstrated. Right? So you demonstrated the left side is equal to the right hand side. So this is what you can do with proofs. And then so your grade 10 teacher probably won't do that. Maybe they will do it. But by the time you get to grade 11, you'll be doing some official proofs, and you have to do that. And then QED, it's been demonstrated that this is right. Okay? All right? So let's see how well do we know these. Okay, so we're going to only do the top 3 questions. So 1, 2, 3. All right? I'm going to give you the final answers and see if you can come up with the final answers. All right, so remember with all of these questions, we split at the equal sign. And we just do the opposite calculation. All right? So my answers are the most simplified answer you can get. So the answer for the first one should be x is equal to -5/6. The answer for the middle one should be x is equal to -6/5. The answer for the last one should be x is equal to 17.02. Right? So, not hard, but also not easy. Try these 3 calculations. Figure out the number you want to try to get rid of. Do the opposite calculation, and see if you can come up with these answers. I'll give you a couple of minutes here. I'll walk around, I'll help, then we'll go over the answer together, and we'll call that a day after that. Good work. I'm going to go over the answers, all right? Like most of you guys got stuck on a little bit of stuff, but overall you sort of understand it, which is great. So I'm going to go over the answers. So remember, the key thing, don't worry about this side, all right? So that's a 4 times x. We're going to divide by 4. Because that's the opposite. Oops. Right? Now, some of the mistakes I saw is people over here will write down divide by 3 or something like that. If I have a divide 4 on this side needs to look exactly the same. Divide 4 here. If you have a different number, or if the number was on the bottom here and you put it on the top over there, you've made a mistake. These things need to look identical. If it's not looking identical, chances are you're making a mistake. So, times 1/4. So now, with fractions, there's 2 ways to proceed. All right? This side is this easiest side. The other side, we can multiply the tops. -10 times 1 is 10. 3 times 4 is 12. And we can simplify that because they're both even numbers. Divide by 2, divide by 2, -5/6. Right? I would prefer if you looked at the original multiplication and you can make it smaller there. Right? If you're not there, that's okay. You can do it here. Right? We'll get better at that. So remember, these are both even numbers. So you can divide by 2. You can leave a little 5 here and 2 there. We multiply the tops, we multiply the bottoms, you get the answer. Okay? So that's where I like to be. All right? Next one. Not that side, this side. That's divide by 2. So times by 2, times by 2. Remember, it's always the same number you're using. I want to get rid of the number of 2. So the question's going to be like, do I add 2, do I subtract 2, do I multiply 2, or divide 2? There's 4 options to get rid of that, right? And then there's only one of them is right. It's always the opposite. It's dividing by 2, so you multiply by 2 to the top. Now, with fractions, it's not necessary. You could draw an imaginary denominator if that makes it easier for you to see the calculation. You don't have to, but you can draw it if it makes it easier. So on the left side, those 2's disappear. On the right-hand side, 3 times 2 is 6. 1 times 5 is 5. And we have a negative. Now, we can put the negative out front, or we can put it on the top. It means the same thing. I usually just put it on the top because it leads to less calculation errors for students, but it doesn't really matter. As long as you have a negative sign out front or on the top number, avoid putting it on the bottom. It's not wrong to put it on the bottom, but that's going to lead to huge number of mistakes for you guys. All right. Last one. For some reason, when I throw a question with decimals, and it throws students off, right? Decimals are the easiest, right? With fractions, you have to use the fraction rules. With decimals, you do the calculation using a calculator. So we focus on the side with the letter. That was divide by 2.3. The opposite is multiply by 2.3. So multiply by 2.3. Multiply by 2.3. Right? So on the left side, a number on the top cancels the number on the bottom. So you divide those two numbers, it gets a 1. On the other side, we grab our calculator and just multiply them out. Turn it on. 7.4 times 2.3, we get 17.02. That's it. Right? So now, those are the rules. That's it. We just build on it. The equations will get complicated, but thing is, can you spot the number? Can you do the opposite calculation? Right? And that's it. And if you can handle that, the rest of the chapter will get easier. It's tricky. It will take a couple of classes for us to get really good at it. All right, so we're going to stop there.